this video, we are going to talk about how to calculate the variable manufacturing overhead price and quantity variances. In other words, we're going to take this variable overhead spending variance and break it down into a price component and a quantity component. You'll see that the calculations are very similar to those of direct material and direct labor, but we'll talk about how the interpretation of these variances is a little bit different since overhead is an allocation. So let's just go ahead and go to our framework here. We'll make a new row for variable MOH for manufacturing overhead. And the standard quantity allowed times standard price, again, we could just take it straight off of our flexible budget right here, $15,850. But let's break it down into the components. So the standard quantity allowed, in this case, would be the amount of direct labor hours per top, so 0.1 direct labor hours per top, since we're allocating overhead based on direct labor hours, times the 15,850 tops. So we should have used 1,585 direct labor hours to make these tops. Now, how much variable overhead should we have assigned to these tops? Well, if we take that amount and multiply it by this rate, this variable overhead rate of $10 per direct labor hour, that tells us that we should have allocated $15,850 worth of variable overhead to these tops as a whole. Okay, now the actual amount of overhead that we allocated to our tops is based on what we have on the actual income statement, $18,069. And then the amount in the middle right here will be equal to the actual quantity of our cost driver used. In this case, our cost driver is direct labor hours. So we've already got that right here, 1,902 direct labor hours times our standard rate or standard price, which is $10 per direct labor hour. Perfect. So now we can calculate the quantity and price variances in a very similar way. So I'll actually just take what we did for direct labor, drag it down, and then double click on it. And we can see that it's this $15,850 minus this $19,020 right there. Okay, so again, let's think about whether this is favorable or unfavorable. You can see that it's negative, meaning it's unfavorable. But why is that the case? Well, if we hold price constant, if this number is bigger than this number, that means we must have used more of our cost driver, direct labor hours, than expected. And all else equal, if we use more of an input, that means our costs will go up and our profit will go down. So that has an unfavorable label to it. All right, and then similarly, we'll just drag the price variance calculation for labor down to the variable overhead row. And we see we have a positive number here, so that's favorable, but let's talk about why that's the case. So the quantities here are the same, and if this number here is less than this number here in the middle, that means that the actual price that we paid for variable overhead was less than what we expected. And all else equal, if our prices are lower for our inputs, that means our costs are less and our profit will go up. So that's a favorable number right there. Now, before we move further, I got to format these so that it's the same as these other columns here. So I'll just go like that. Okay, very good. That looks much better. Let's go ahead and double check to make sure that we did this correctly. So we'll drag this down right here. And that's just the sum of these quantity and price variances. And overall, that's a negative number, so that means it's unfavorable. And if we go up here and check on this spending variance that we calculate up here, sure enough, it's the same thing. Okay, so again, what we did is we broke this down into a quantity and a price component. Now, you have to be careful when interpreting the price and quantity variances for overhead because these are allocated numbers. So when you look at this quantity variance for variable overhead, you might recall that when we're making tops, some of that variable overhead may consist of glue that you use in the wood, or maybe qualsol or something to treat the wood to protect it against moisture. Or it may be oil that's used in the lathe or machines that you're using to make the tops. All right, so you might think that this means you're using more of those components. It really doesn't mean that, though. There's a good chance that you probably did use more, but really what happened is we used more of our cost driver. And if that cost driver is accurate, that should mean that we used more of our inputs than expected. But it doesn't necessarily mean that, okay? So you have to be careful with that quantity variance for variable overhead. The price variance being favorable, that definitely could mean that you purchased the inputs, the oil, the qualsol or protectant, and the glue at lower prices than expected. But it's a little bit harder to know which of those inputs it is because this is an aggregate of all those inputs. But at least it tells you, hey, it's one of these indirect materials or indirect labor components, or maybe it's energy, okay? Anyway, it's a little bit harder. It's not as informative because it's overhead, and it's just a mixture of a lot of different costs there. All right, well, now that we've calculated those and talked about those, let's go ahead and tally these numbers up over here. So we'll just say VMOH quantity variance, and we'll set that equal to the 3,170 unfavorable, and the variable manufacturing overhead price variance we'll set equal to the 951 favorable. All right, now just like these other variances here, these often have different names associated with them. So the variable overhead quantity variance you often see as variable overhead efficiency variance. And I don't know why, but this variable overhead price variance is often called the variable overhead spending variance. And that is really confusing because that's also what I'm calling it up here. Okay, so just recognize that sometimes when you see that variable overhead spending variance, they may be referring to the variable overhead price variance. All right, but that's how you calculate those variable overhead variances, and not too difficult, but the interpretation is a little bit different than the direct variable inputs.